In this example, I want to show you how you can use a mean value theorem to find the C that's mentioned in the conclusion of the theorem. So first we have a question that says find all values of C that satisfy the conclusion of the mean value theorem, and that's for the function f of x equals minus 2x cubed plus 6x minus 2 on the closed interval minus 2 to 2. So we need to check the conditions of the mean value theorem. And the first condition is that we need to check to see if f of x is continuous on the closed interval AB. In our particular problem, this closed interval is going to be minus 2 to 2. The second condition we have to check is to make sure that f prime of x is defined on the open interval AB. Our open interval would be from minus 2 to 2. And being defined in terms of the derivative being defined on the open interval is the same thing as saying that the function is differentiable. And then the conclusion of the theorem says that there is some C in that open interval AB such that f prime of C is equal to f of B minus f of A over B minus A. And so f of B minus f of A over B minus A, we can calculate that because we'll know the function A and B. And then we're trying to find the value C where the derivative is equal to the average rate of change. So here's our problem again. So first we check and we see that f of x is continuous on the closed interval minus 2 to 2 because f of x is a polynomial and therefore it's continuous everywhere. The derivative of our function is minus 6x squared plus 6, which is also a polynomial, so it's certainly defined on the open interval minus 2 to 2. And therefore we know that f of x is differentiable on minus 2, 2. And so we're going to stick our derivative in on the left-hand side and evaluate it at c. So minus 6c squared plus 6, that's f prime of c. And that should be equal to f of b, which is f of 2, minus f of a, which is f of minus 2, divided by b minus a, or divided by 2 minus a negative 2. We end up with f of 2 is minus 6, f of minus 2 is 2, so we end up in the numerator with minus 6 minus 2 divided by 2 plus 2. So we get minus 6c squared plus 6 is equal to minus 2. So we need to solve that quadratic equation to determine the values of c that satisfy the condition of the theorem. So again, we have minus 6c squared plus 6 is equal to minus 2, and we have to make sure that c is in minus 2, 2 once we find the c. So we have to be careful because in some of these problems can actually find values of c that actually are not in the interval in question. So when we get our values of c, we need to confirm that they're actually in that interval. Well, solving that quadratic, we move everything to the right-hand side. We get minus 6c squared is equal to minus 8. Divide everything by minus 6, and we get c squared is equal to 4/3. Taking the positive and negative square root of both sides, we get that c is equal to plus or minus 2 over the square root of 3. Since we can check and see that 2 divided by the square root of 3 is somewhere between minus 2 and 2, the values of c that satisfy the theorem are plus and minus 2 square roots of 3.